Good evening, class. This is my new YouTube channel, The Chemistry World, and I, Divya Malviya, is going to teach class 11 students some basic concepts of chemistry. So, let us start. Unit 1, Some Basic Concepts of Chemistry. Chemistry is the science of molecules and their transformations. It is the science not so much of the 100 elements but of the infinite variety of molecules that may be built from them. This was definition according to Roald Hoffmann. Now, recalling previous knowledge, matter. What is matter? Matter is anything that occupies space and has mass. For example, book, pencil, pen, water, air, all living beings, etc. are composed of matter. They have mass and occupy space. States of matter. There are three states of matter. They are solid, liquid, and gas. Solid, liquid, and gas. Solids. Particles are very close to each other. There is not freedom of movement. Solids have definite volume. Solids have definite shape. Liquids. Particles are close to each other, but they can move around. Liquids have definite volume. Liquids do not have definite shape. Gas. The particles are very far apart as compared to those present solid or liquid states, and their movement is easy and fast. Gases have no definite volume. Gases have no definite shape. Now, classification of matter. Matter is classified into two: mixtures and pure substances. Mixtures are classified into homogeneous mixture and heterogeneous mixture. Pure substances are classified into elements and compounds. Now, mixture. A mixture contains particles of two or more pure substances which may be present in it in any ratio. Hence, their composition is variable. Pure substances forming mixture are called its components. For example, sugar solution in water, air, tea, etc. These are all mixtures. They are present in any ratio. Their composition is variable. Homogeneous mixture. In this, the particles of components completely mix with each other. This means particles of components of the mixture are uniformly distributed throughout the bulk of the mixture and its composition is uniform throughout. For example, sugar solution. Sugar solution is an example of homogeneous mixture. In this, particles are uniformly distributed throughout and composition is also uniform. Air is also an example of homogeneous mixture. Now, second is heterogeneous mixture. In this, composition is not uniform throughout and sometimes different components are visible. For example, mixtures of salt and sugar, grains and pulses, along with some dirt are heterogeneous mixture. In this, composition is not uniform and sometimes components are visible. The components of a heterogeneous mixture can be separated by using physical methods such as simple hand picking, filtration, crystallization, distillation, etc. Now, pure substances. Constrained particles of pure substances have fixed composition. They have fixed composition. Copper, gold, silver, water, and glucose are some examples of pure substances. Glucose contains carbon, hydrogen, and oxygen in a fixed ratio and its particles are of same composition. So, therefore, it is a pure substance. Now, pure substances are of two types: elements and compounds. Elements. Particles of an element consist of only One type of atoms. These particles may exist as atoms or molecules. For example, sodium, copper, silver, hydrogen, nitrogen, oxygen, etc. are some examples of elements. Here H2, N2, O2, they exist as molecules, and sodium, copper and silver exist as atoms. Now compound. When two or more atoms of different elements combine together in a definite ratio, the molecule of a compound is obtained. The constraint of a compound cannot be separated by physical methods. They can only be separated by chemical methods. Examples are water, H2O, ammonia, carbon dioxide, etc. There is a picture also where there is a representation of atoms and molecules. These are the atoms of hydrogen, oxygen, nitrogen, copper and sodium. And this is the molecule of hydrogen, which is made by two atoms of hydrogen. H plus H gives H2. Similarly, a molecule of oxygen, two atoms of oxygen makes one molecule of O2, that is oxygen. Now, this is a water molecule H2O, this is a carbon dioxide molecule CO2. As you are very familiar with these molecules, water and carbon dioxide. Now we are going to the next slide. Laws of chemical combination. First law is law of conservation of mass. This law was put forward by Antoine Lavoisier in 1789. Mass can neither be created nor destroyed. This is called law of conservation of mass. Mass can neither be created nor destroyed. It is the law of conservation of mass. Now, second is law of definite proportions. This law was given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. Proust worked with two samples of cupric carbonate, one of which was of natural origin and the other was synthetic. He found that the composition of elements present in it was same for both the samples as shown below. So here the composition of natural sample is the same, as you can see, and synthetic sample is also the same. Thus he concluded that irrespective of the source, a given compound always contains same elements combined together in the same proportion by mass. It is sometimes also referred to as law of definite proportions. So what we have understand that a given compound always contains exactly the same proportion of elements by weight. Okay, now the next slide. Law of multiple proportions. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. That means if two elements जब combine होंगे to form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. For example, hydrogen and oxygen combine to form two compounds, namely water and hydrogen peroxide. As you can see, here we have taken hydrogen 2 gram, oxygen 16 gram, and now it has become water 18 gram. And now the same here, hydrogen 2 gram, oxygen 32 gram, it's now the double. And we have got hydrogen peroxide H2O2. Here oxygen is double. Here the masses of oxygen, that is 16 gram and 32 gram, which combined with a fixed mass of hydrogen, that is 2 gram, bears a simple ratio, that is 16:32 or 1:2. सो दैट मीन्स अगर दो एलिमेंट्स फॉर्म करेंगे एक से ज़्यादा कंपाउंड, तो जो मासेस होगा उनका एलिमेंट का, वो उनका जो रेशियो होगा वो स्मॉल होल नंबर्स, दैट मीन्स they are in the ratio of small whole numbers. They are in a fixed mass of the other element are in the ratio of small whole numbers. Here the masses of oxygen bear a simple ratio, that is 16 is to 32 or 1 is to 2. 1 is to 2. Now Gay-Lussac's law of gases volumes. This law was given by Gay-Lussac in 1808. He observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. Thus 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water vapor. Hydrogen plus oxygen give water in the ratio 2:1. So means कि when gases combine, जब gases combine करती हैं या chemical या produce होती है in a chemical reaction, they combine to form a simple product, that is in the they combine in the simple ratio by volume, provided all gases are at the same temperature. Law of multiple proportion is for the mass, and Gay-Lussac's law of gases volume is for the volume, is by volume. ये लॉ मल्टीपल प्रोपोर्शन मास के लिए है, इसमें हम मासेस लेते हैं 2 ग्राम 16 ग्राम देन फॉर्म 18 ग्राम, एंड Gay-Lussac's law of gases volume, इसमें हम वॉल्यूम लेंगे 100 ml 50 ml 100 ml, ratio is 2:1. Now Avogadro's law. In 1811, Avogadro proposed that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Avogadro proposed that equal volume of all gases at the same temperature and pressure should contain equal number of molecules.